All right, so today we'll talk about our next and last addressing mode, which is indexed addressing. In this lecture, we'll talk about this addressing mode. We'll look at a couple of examples to understand how this addressing mode works. Okay, and in the future lectures, we'll actually see the significance of this addressing mode. So at this point, you may not understand the importance. You might not see why it is needed right now. And we're not trying to even motivate you here, but we'll probably try to show you how it works. But after this lecture, when we'll start talking about the loops, then we'll probably see the more connection between the loop and indexed addressing. So here is our first example for you. We just have a couple of lines here. If you look at these lines, can you take a look at the line number 2 and line number 3? So look at how those lines are a little bit different than what we have seen so far. How it is different, because you see here with each of these lines, there is a comma X, which we have never seen before, right? So that is something which brings indexed addressing into picture, okay? Because these two lines are indexed addressed instruction. Now, we probably will understand a little bit better soon, but let's see how we calculate it. So first of all, if we try to understand what is the operand in those two lines, we actually cannot tell what is the operand, because remember, in any of the instruction except the inherent, you can directly look at the instruction and tell what is the operand, right? But right now we cannot tell what is the operand because this is like indexed. So in such cases, meaning the instructions with the addressing, indexed addressing, we have to calculate the operand. So whatever the information you are given, from here you will calculate the indexed addressing, meaning the operand. Now to calculate it, we need a small formula, very small formula. The formula is sum of two different items. One is the base address, another one is displacement. How do I get these two information? So once you have these two pieces of information, then you will be able to calculate the operand for each of the lines which are indexed addressed. Okay, so here is our base address. Your base address is always the content of the index register. Now remember, we have two different index register, right? Y, X and Y, right? So whenever you have a comma X, so you can guess at the time the content of the index register X will be your base address, or if it is comma Y, then it will be content of the index register Y. So at this point, it will be the content of index register X. So you know here, so the content is 0040, right? That is what we are loading into index register X. So that is my base address in this case. I also need one more piece of information, which is displacement. How can I find the displacement? Displacement actually is given with each of the line. You see here in the line number 2, displacement is $25, meaning in hex, right? In the line number 3, displacement is $34. So you pretty much you are given the displacement in the line. So now you have the base address for both lines, which are same, which is same, right? 0040, but the displacement is different for to each line. So from here we can just apply the formula. We can calculate the operand. Look at how we calculate the operand for line 2. We just added 0040 plus 25, right? That's my base plus displacement, and we got the operand, which is 0065. And for the second line, meaning the third line, base address plus displacement, again we got the operand, which is 0074. Now once we got this operand, we can just replace these three lines by the three lines we have at the right side. So what I did was I just replaced the operand part by the operand we calculated. See? Now if you look at the three lines that you have at your right side, we understand what they are, right? We pretty much know what they are. So That means every time you are given any instruction in the indexed addressing mode, you have to calculate the operand. Now once you calculate the operand, we understand the rest, right? You might be wondering why we need to do all of these, meaning why we need to deal with the indexed addressing instruction and then calculate the operand, why we can't write the 3 lines that we have on the right side, right? I'm sure that you will get the answer very soon. You don't have to wait, because once you go to the loop, you'll see why we need the index addressing. So and that's why exactly we are discussing the index addressing just right before the loop. We have not discussed this this addressing mode until now. Just waiting for the loop for our discussion to come. Now here, if you see a question like this, which memory location is addressed by the line number 2? Remember, if you see this question, you will be actually given the line you have at your left, okay? And then you calculate the operand and then write the line you have at your right side, and then it's actually easy to answer this question, because in the line number 2, the address which is memory location which is addressed is actually 0065. So basically the operand. And for the line number 3, what is the memory location is address? Of course, there's 0074, right? But remember, you'll be asked this question given the line you have at the left side. So you have to calculate the operand first, and then you answer this question. Okay? Once you calculate the operand, it's easy. Now let's take a look at some more example. Now here we have some another example. We have just 4 lines this time, right? What is different here? Just by looking at this, I can tell the first thing that is different here is now we have comma y, right? Instead of comma x. Remember I said it can be x or y because we have 2 different index addressing. And how can I calculate it? I think I just did everything at once because we now understand a little bit better. But here is the catch. We have indexed addressing in line number 2. We have indexed addressing in the line number 4, right? So for line number 2, it was actually easy because the base address is 007A, right? Because that is the content of index register y in the first line. And we also know the displacement, which is 15 in hex. We calculated the operand, very simple, just base plus address. I'm saying the displacement, we got it. And we replace that in the line number 2 here, right? 008F. How about line number 4? Here is the catch. In the line number 4, by the time you hit line number 4, you see here we actually increment index register y by 1. Do you see I and y in the line number 3? That means you are incrementing the content of the index register y by 1. So that means your base is changed. So by the time you hit line 4, you actually have a base address of 007B. So don't just look at the first line and copy the base address. So look at the other lines as well, okay? So the base address is changed. That's why I highlighted it, as red. And then my displacement is 65, but the 65 is given in decimal. Be careful, okay? We always convert everything into hex. So we convert it into hex, which is 41 in hex. And then we are adding the operand plus, I'm saying the base address plus displacement to calculate the operand, which is 00BC. I think we understand the rest, right? Now if we just replace it, we'll get these 4 lines of instruction we have at the right side, and I'm pretty sure that we understand all the 4 lines at the right side, okay, once we convert it. Any question here? Alright, so let's try another example. Now again, I pretty much have the same example, same lines of conversion, but can we understand some additional thing from here? So let's say if somebody asks me this question, what data is loaded into accumulator B by line 2? Now remember, when we'll be asking this question, we'll actually give you the lines of instructions that we have at the left. So we first have to convert it to line we have at the right side. We know how to convert it, right? Just to calculate the operand for all the lines which are indexed addressed. Now after that point, it's actually easy to answer the question, because what we are asking is what data is loaded into accumulator B by line number 2. Let's look at the line number 2 here. So what data is loaded? This is an address, right? Which is 8F, right? So 8F is an address which is, I circle the I'm saying the data, which is F2, right? So that means my answer is F2. That means F2 is loaded into accumulator B in line 2, right? But remember, we cannot answer this question unless we convert everything into the right 4 lines. Because you cannot answer this from the left side, right? Because you first have to calculate the operand, then you can answer the question. Once you convert it, it's easy. Let's try another question. Let's say, what will be the content of accumulator B after line 4 is executed? That means after you are done with all the 4 lines. What will be the content of B? Now let's see what happens in the B. You see the B is actually, something is changing in the B in line number 2 and 4. So in the line number 2, you are loading something into B, right, which was F2, and the line number 4, you are subtracting from something from B. So what you are loading and subtracting? So you are actually loading F2, right, and the line number 4, you are subtracting AF, right? So basically what you are doing is, you are doing a small subtraction, which is F2 minus AF, right? Because in the line number 2, you are loading F2. The line number 4, you are subtracting AF from F2. And then you end up with 43 in B, right? And that is your answer. See, the answer is actually easy once you convert everything into just, meaning you calculate the operand for all the lines, you have the indexed addressing. The rest is, simple. Any question? Okay, let's try something else. See, I just have two lines here, and again something with the indexed addressing. See, the first line I'm loading something into LDY. In the second line, looks like this is an indexed addressing line, but you see something weird here. Do you see there is nothing before the comma? See here? Did you notice there is nothing before the comma? Now this is actually syntactically correct. That means anytime you see something like this, that means this is correct, but before comma you actually have 0. So you can ignore 0. So if you don't see anything before comma, then assume there is a 0. That means the displacement is actually 0. Do you see what I'm saying? Displacement is 0. Okay, and this is an indexed, addressing. So basically you are loading something into stack pointer, right? But before doing everything, we first have to calculate the operand, right? For the line number 2. Now, can anyone here tell me what is my base address? Is that 005A? Do you think 005A will be loaded into index register Y? See, the 005A in this line is an address. Here is the catch. So basically, the base address is 0023. Be careful, okay? So the base address is 0023. So I can, now you know why base address is 23, right? Because that is the content of my Y. Now, how do I calculate my operand? Again, base plus operand, base plus displacement, right? See how I calculate it here. My base is 0023 and my operand is 0, right? Yeah. So I calculated that. So I got my operand, which is 0023, right? So I wrote that here. Now, once I have these 2 lines, can you answer the question that I have at the top? See, the question I have is, what data is loaded into stack pointer SP by line number 2? You see here in the line number 2, we are loading something into stack pointer 2, right? Okay. What I am loading? This is again an address, right, which is 0023, right? Yeah. Let's go to 0023, which is actually here, right? And again, remember, a stack pointer is a 2-byte register, right? So we are actually loading FDB9 into stack pointer. This is actually an interesting question. You just have 2 lines. There are a lot of excitements. So you first have to calculate, you first have to find the base address, and then you know that there is a displacement. You add the base and displacement to get the operand. Once you have the operand, again you look at the memory map to find what is the operand, and that will be loaded into stack pointer, right? Remember, if you are given this question, you'll be actually given the lines that you have at your left side. 2 lines. And you'll be asked this question, what data is loaded into stack pointer SP by line number 2? So the first step is always calculate the operand. For all the lines, you have the indexed addressing. And then you do the rest. Any question? Okay, so if we don't have any question, I'm hoping that we should be ready for our next quizzes. In these quizzes, you will actually see pretty much the similar questions that you have seen here, okay? So all the indexed addressing question, meaning you'll be given a couple of lines, and then you'll be answering this question like, oh, okay, what is the memory location address by the line, or what will be the content of these, that, okay? And I'm sure that we love quizzes, and there is no way I know that some of you probably can't wait. So here is our next two quizzes again, but this is based on all the examples that you have seen here. And another important thing is we really need to understand the index addressing to understand the loop, okay? But the next lab, which is lab 4, is based on the loop. Based on the loop. So to start the loop, we really want to understand the index addressing. This is actually easy. The only thing that you need to know is how to calculate the operand. The rest is pretty straight, because once you convert it, all those scores that you see at the right side in most of the slide is actually simple than what you have seen so far. Let me stop the presentation here so that we can try our quizzes and also lab.